Are you seeing the slide? Okay, thank you. Okay, just let me just. Now, is it audible? Is it audible? Hello? Now, can you see? Is it audible? I have made it maximum. Ask Imtiaz.
So it's audible, sir. It's very clear.
Okay, thank you. So kind of you. Hello, is it audible?
Yes, sir, now it's audible.
Thank you.
That's perfect. Okay, sir.
Good afternoon to everybody. Are you listening to me?
Good afternoon, sir.
Just give me feedback. Are you listening?
Yes, sir.
Yes,
sir, we are listening to you.
Slide visible?
Yes.
Thank you.
Yes, lights are visible and it's very clear.
Wonderful. Yesterday we stopped at knowing about the meaning of xenobiotic. Xenos means foreign, stranger, outside the body, external to body. Biotic means that particular entity, chemical or an influence factor, which exerts some measurable biological effect. In other words, technically it is xenobiotic, but on common parlance, it is nothing but pollutant, contaminant, right? Extremely important. This concept is important. You should know that. It is highly toxic in nature. Toxic means poisonous, has the potential of causing harm, damage to the health of the receiving organism. It could be even plant, it could be a mountain, it could be human being, but xenobiotic has the potential of causing the harm to the respective health of the part of the entity in the environment. And of course, human being also is a part of environment. So human being's health also gets upset by the exposure to these xenobiotics. They cause various diseases, especially very dangerous diseases like cancers. They are not easily degraded. They cannot become non-functional or docile. They are very hard. They cannot be metabolized easily inside the body. Metabolism is a process which detoxifies most of the chemicals that we take. That is not possible. They remain poisonous and remain in nature for a very long time. Remain in nature or in its original form or modified form for a long time, so that everybody is exposed and everybody is in a risk and danger. That is the feature of these pollutants or xenobiotics. So we stopped at this and we go on now with what is called basic concepts. We had a kind of introduction yesterday about what is this, the meaning, the definition of environmental pollution. Today we learn about real concepts, and these concepts are very important. Please listen to it very attentively. And if you have some doubts, please jot down those doubts. You can put it in chat box. We will answer that. And also, I would like you to, note down certain salient features which are not appearing on the slide. I would be telling so many technical terms. You should be able to jot down those technical terms because that may come for the examination. So your attention is extremely important. It is not just what the slides that are projected that can be asked, but what other terms that I tell, which is not in the slides, also can be asked for testing your, absorbability. So kindly note down, make some short notes also of those points which are not present in the slides, but you find and I find important, right? With this, let us move on to the concept number 1, which is called exposure concept. Now, exposure is exposure to xenobiotic, exposure to pollutant, exposure to that entity which has a potential to cause some aberration, some difficulty into some uneasiness or disease of the organism. Now, organism, let us forget any other thing. We concentrate on human being, right? For human being as an example we take, and what is the effect on human beings, we concentrate more. Nonetheless, the damage can be done to even other entities. The exposure centers around two important factors called dose, that is the concentration or the quantity of the xenobiotic, and time, how far, how much time you are exposed to that particular danger or dangerous component. That is, these are the two important determinants in exposure. Exposure is engagement you get exposed to. Dose is the concentration of that pollutant or xenobiotic. Time is how far, how much time you get engaged in that with the contaminant. That is two factors we need to remember. Now, this is the first class of or first type of exposure known as acute exposure, which is defined as exposure to that particular contaminant or xenobiotic in a sudden and large dose, high dose, but short time. So generally, if you are exposed to very high concentration of carbon monoxide for even or cyanide, even for 1 minute or even for some seconds, the effect can be felt. That means the concentration of the pollutant is very high, and what you are exposed is the time is very small. So dose is high, time of exposure is small. That is classed as acute exposure. The second one is called chronic exposure. Here the dose is small, but on a long-term basis. Some small doses continually you are getting exposed. This is second type of exposure. So in exposure you have two small types, acute and chronic. Acute, high concentration, small time. Chronic, small concentration, very long time. Generally, all of you know, if I ask you which is of both are dangerous, but if you want to rank, if you feel, how do you rank these two? Whether chronic is bad or acute is bad? Both are bad, but which is more bad? That kind of a question if I ask you. Generally, people will tell acute exposure is dangerous, sir, because sudden death or sudden disease, sudden change happens there. But contrary, in pollution studies, in environmental studies, it is, what they say is slow poisoning or slow killing. Small doses for your lifetime, you get exposed. The chronic exposure effects are more dangerous for the following reasons. The first reason is, although the small dose is there, the change cannot be felt. The change is felt only on a long-term basis when you get exposed to years and years. And when that change happens, you cannot revert back. It is impossible or it is almost difficult to come back to normalcy. Whereas in acute exposure, you get the effect immediately and everybody catches the attention. It is, if I want to give you an example, suppose you are walking or cycling on the road and you fall for some reason and your leg is broken or some blood is oozing out from your limb or your leg, everybody will rush to you, is it not? Because they are seeing blood, they are seeing change, they are seeing suffering. They want to help and run. They will run and come and help you. And that is an acute exposure, because otherwise you are so healthy, so nice cycling, and you fell suddenly. It is a big dose of bad incident that has happened. And within the short time, you got the attention also. There is an attention benefit also. Whereas in chronic exposure, bad things you are getting exposed to, but nobody is noticing. For example, we are inhaling carbon monoxide, carbon dioxide, oxides of nitrogen, so many varieties of pollutants in the urban environment in such small doses that we don't realize the effects. Effects are always there. They are generally cumulative, but when effect comes, by that time, the disease has already precipitated and set in. So chronic exposure, by all means, is more dangerous from the point of exposure and also effects, biological effects, contrary to very large doses and small time, because attention does not get, or you cannot catch attention, and so you tend to ignore because the changes are so subtle, so feeble, and so small. So chronic exposure is a deceiving kind of exposure, whereas acute exposure catches attention and you can get reversible damage, whereas in chronic exposure reversible damage is not possible and you have to suffer. So in these are the two types of exposures. The other point in exposure that we should to remember is an exposure effective concept. Effective exposure concept means what? Say for example, I am a teacher. I am a teacher since last 30 years. If I say I am exposed to teaching environment for 30 years, right? 30 years is my service. So exposure is 30 years. Is it true? No, it is not true. 30 years is for account of what is called salary, monthly, yearly, quarterly, everything I have got. But whereas in the class, before the, as a teacher, before students' engagement, and that is very small, is it not? You see, today, whole of the day, I engage with students for only 2 hours. So my exposure to students as a teacher is only 2 hours for 24 hours, right? Other 22 hours I did not teach. So my exposure during in occupation or in any way where the exposure to Xenobiotics is possible in the environment is only 2 hours. So 30 years means 30 days, 30 into 12 into 30 days into 2 hours. That is my effective exposure time. Effective exposure means actually what is your exposure, right? Actual what is your exposure to that particular danger. For example, an industry man works for 8 hours a day. During 8 hours, all the 8 hours he will not be doing the job, right? So 1 or 1.5 hours he will take lunch. For 25 minutes he will take coffee in the morning, coffee in the evening. That should be deducted, and it should be taken only when he is doing the work at the workplace or work environment or work pollutant exposure. That concept is known as effective exposure concept, because that is what matters. That is where you are exposed to pollutants. So that is yet another kind of exposure, effective exposure concept. The last one is effective dose concept. Exposure, while we talked we talked in the first instance dose and time. In the second instance also we talked about the time and dose. And the third, we are talking dose and concept in 3 ways. Now, what is that? The first one is active ingredient. Well, there are so many pollutants at the same time we are getting exposed, but there are, say, so for example, if there are 25 pollutants in the environment to which I am getting exposed, the possibility of damage associated could be only few among these 25. Is it not? So there is humidity, which is also a xenobiotic. But for humidity, even if I get exposed for a long time, I may not get what is called precipitating into diseases. So what is that active ingredient which definitely causes measurable biological effect? That is called active ingredient. Even in drugs and even in tablets, you see, the active ingredient is always very few, that which causes the danger, that which causes the negative health effect. So that is to be understood, active ingredient exposure. Absorbability, once you take the dose, how much you can absorb. If you take 500 milligrams of paracetamol, your capability, your otherwise health conditions can absorb only 300 milligrams, right? So there is always called what is called some kind of individual capacity of absorbability. So absorbability is also a factor in exposure. The last aspect is body mass index. Whether you are a child, whether you are an adolescent, whether you are an adult, whether you are an old-aged person, male, female, these are other factors. And also the body weight and also body mass is extremely important for the prescription of dose, so that the disease can be countered. So these are the factors associated with what is called effective dose concept. Dose is important, that is concentration is important, the quality is important, absorbability, active ingredient, the time of exposure, all this become important in exposure. We need to ask further questions exactly to elicit the damage that is possible or that is inherent with the exposure of to the pollutants. So this concept is extremely important, dose and exposure concept. And you have another associated concept with dose and exposure, which is very, very interesting and important. Now, if I put this particular graph, you have the middle line, which is the health effect. From here, the zero health effect, here the maximum health effect. That means if you are here, you are healthy. If you are here, you are very sick. That is how it goes as a qualitative measure. And if the graph is like this, it goes on the top, and it is positive health effect. If graph goes on the negative, that is, it is negative health effect or disease or unwanted or not needed, that kind of a issue. Now you observe this particular graph, you will see that if you are getting exposed to mercury, right, even in the small dose as near to zero as possible, it is having a negative health effect. That means here is a particular xenobiotic, a pollutant, which is highly, highly, highly dangerous, because even in a very small dose and very less time, it gives you bad, or it gives you health effect, negative health effect. Such pollutants are highly, highly dangerous, because the quantity is immaterial, that is very small, and also the time also is very small. It not over a period of time, immediately it causes negative health effect. And that is the reason why for mercury thermometers are abandoned. There is no more mercury thermometers now. Previously, mercury was used as a thermometer in the thermometers for measurement of temperature. Now mercury, because of the bad nature, it is banned. Mercury that is reason why it is banned. It is also banned for several other reasons, but mercury as it is a metal, which is the liquid, which is vaporizable at room temperature, gets absorbed through skin, inhalation and ingestion. So it is very, very highly dangerous. So this is a class of xenobiotics. When there is no dose or small dose, health effect is always negative. Similarly, if you go to the copper, you understand here, copper starts from here, from the negative to positive. That means this amount, this amount from here to here, that is this particular amount, is needed for the body. If you do not have this particular concentration inside the body, then it is bad. That means copper is essential to some extent, and if it goes on increasing, the dose increasing, you get up to here, up to this dose, it is beneficial. After this particular dose, this concentration, then it tends to be dangerous. That means copper has, unlike mercury, beneficial effect, but something is essential, very much essential. That is why copper is a cofactor in several human enzymes, cofactor or coenzyme. It is also known as metallozyme. So there are metals which are important, and these metals are conducive, advantageous to metabolism. So copper is one such useful material. However, after it crosses the threshold level, then copper also exerts negative health effect. Up to this concentration, it is tolerable. This is very good health. From here onwards, the health deteriorates. And from here to here, it is always causing some kind of measurable bad disease effects, copper poisoning. Similarly, the third metal is calcium. And calcium, it is little more needed than the copper. That means from here to here, if you do not have, they are also danger. So you should have. So it is also a metallozyme. It is also an essential metal. Calcium is extremely important, and it is needed in large dose. And you can go up to here. That means calcium can be, that means from here to here, the dose is needed, is necessary. It is more useful than copper, right? All the three metals, negative, very bad, mercury, it's okay, middle, good, needed, metallozyme, copper, calcium is little more useful to when compared to the copper. Please mind that is optimal health up to here you have positive effect. If it crosses that particular level, that also shows negative effect. Now summary point in this particular graph is all the materials or metals or xenobiotics at a particular dose, if it crosses a particular limit, cause negative effect. That is the first rule. That means the dose becomes determinantal. The quantity or the level that we need depends from the metal to metal or xenobiotic to xenobiotic or pollutant to pollutant. That is how we differentiate from food to other poisonous chemicals. Dose becomes extremely important, and it is the dose that determines the health, right? That is the concept of dose and health. One is exposure time, the other one is dose and that is quantity and health. Now, concept number 2, we need to understand, and this is regarding how these xenobiotics enter the body, enter the human body. The human body, as I told you, is an example, but in environmental studies, human body is one such example. There could be so many other parallel species, parallel animals, microorganisms, even for that matter, mountain, lake. They are all included, sand, soil. They're all included in the environment. But for ease of understanding, I have put only human body because that we can relate it very easily. But for the human body, the engagement or the exposure, after exposure, depending on dose and the time, there are 3 routes that these xenobiotics, which are external to human organism, can enter inside the body. Because what is outside is something, but once it enters inside, it is so many other things. What is outside and we don't get exposed, it is okay, even if it is a poison. But what is outside, if it enters inside the body by inhalation, by ingestion, by skin absorption. Inhalation is through respiratory system, that is our nose, right? Our lungs, our trachea, our alveoli, these are all respiratory system, part of respiratory system, and the process is known as inhalation. Ingestion is through mouth, that is what we drink and what we eat, our solid food. Ingestion is eating. Skin absorption is touching, that particular xenobiotic touching. Skin, as all of you know, is the largest organ in the human body. It is covered entirely to your human body, and xenobiotics can touch and enter in any part. So skin also becomes important. It is only these 3 routes that is possible for all the extraneous xenobiotics that can find entry into the human body. So what are the 3 routes? Inhalation, that is respiratory system. Ingestion, that is the gastrointestinal tract. Skin, these are the 3 organs that has entry system, which are called portal entries, port, where ship stands and other things can enter. So the materials will enter. So this is inhalation, ingestion, and skin absorption. This is how on a picture we can illustrate. You have skin absorption. Skin can go anywhere. Just a hand is taken as a example. But what are the type of xenobiotics that tend to go inside through the skin? Spillage of so many organic fluids, dusts, liquids. They are, because skin has pores, so skin also becomes a portal entry. Inhalation, very important. In inhalation, what we should remember is if the xenobiotic is in the gas form, vapor form, small particle form, and that is suspended or soluted, solvent is air. For the solute or that is solid, then it is called an aerosol. And aerosols, vapors, dust, gases, which are in the environment, we are incessantly inhaling inside the body. And respiratory system starts with nose, lateral and frontal sinus, this trachea, left lung, right lung, then tracheole or bronchiole, finally ending with alveoli. Okay. But this is the air exchange region. This is the portal entry. The sizes of lumen of these cavities also become important, because in case of dust, if it is large dust, it can be settled somewhere here, it can settle here, it can settle. If this lesser the size, lower the the traversing So, okay, that means if the dust particle is lesser in size, we should be bothered because it can go into the lower respiratory tract and cause what is called lower respiratory infections. Upper respiratory, lower respiratory. Upper respiratory generally reversible, because when you sneeze, when you expectorate, these particles that are settled can come out easily because of the large size, what we call it as mean mass diameter. If the mean mass diameter of the particle is big, then it is possible to go away or reverse the effect. But if the mean mass diameter is very small, like gases and vapors and very fine dusts and aerosols, they can go to the lower tract and create problems in the air exchange region, which is very, very important for us. Lungs, they give you oxygen, and these membranes are so nice and so fine, they cannot be contaminated. If a particle size is so much small and get clogged here, it is impossible to remove. The whole bronchiole becomes completely dysfunctional. That means that much of capacity of air exchange is lost, So we have to be careful, and inhalation is extremely important when you compare to ingestion and skin absorption, because I will tell you the reasons little later. Inhalation is extremely important, more determinantal than ingestion and skin absorption for a variety of reasons, which we learn as we go on. So, and the ingestion is through GIT, that is other route, gastrointestinal tract, goes to stomach, goes to intestines and all the organs. Something can be absorbed by the blood and circulated to all the bodies. So ingestion also is important. Skin absorption is extremely important because it is the largest organ. Some fluids like organic solvents are very, very soluble. They can very, very permeable. They can penetrate into skin also. So these are the three routes of entry, and that is the basic concept here in the entry of xenobiotic, entry of chemical or pollutant into the human body. So the routes become also extreme, or portal entries become important. The concept 3. Now this is extremely interesting. Please follow this. This is called, this particular concept is now called as eco-kinetic properties of a chemical. Now what is eco-kinetism? Eco means environment, kinetic means move. That is movement of xenobiotic, movement of chemical pollutants, movement of so many antigens in the environment. Eco is in the environment, because when at a source, when the pollutant is generated, it will not stay at there only. It will move in the medium of air, water and soil, which is part of environment. They become vehicles to carry environment from the source to the target, is it not? So it is extremely important. What is that mechanism of this chemical pollutants generated from a source and distributed in the environment? And this is what is known as eco-kinetism or eco-kinetic properties of xenobiotic. Now, schematically, to make the things simple, I have given this sketch. For ease of understanding, I have made this. Let us just imagine, it is imaginary, that this rectangle represents environment. That is to understand. You can't picture environment at all, because environment encompasses everything. You can't limit at all. But ease of understanding the principle, I have made this big rectangle as the environment for ease of understanding. Now, depending on the chemical, nature of quality, quantity, it is released into the environment by the source. Now, what is the source? Source could be a chimney. Source could be an exhaust pipe of a scooter or a car. Source could be a fireplace where you burn some kind of fuel and pollutants, unburnt, unconverted, some remnants, residues can come out into the environment. And when they come out, when they are released into the environment, they are capable of moving in the environment. They move into the environmental body. So it is an environmental body which is lifeless, but what is important is movement. They move from one place to the other place, governed by so many physical principles: wind velocity, wind pressure, wind speed, air speed. It depends how fast, how slow, by default conditions, temperature, humidity, biotic, abiotic reasons. But principle is they move from one place to the other place, right? So it is extremely important that once the antigen, that is pollutant, is released, it moves in the compartments of the environment, into the environmental body. And what is the principles governing the movement? It is transported from one place to other place. It can undergo photochemical reaction because they are chemicals. Some chemicals are sensitive to the sun. Photo means sun, sun's rays, and sun and light. So it can get converted. What was original can get converted into some other thing. So it can undergo photochemical reaction because sun is there. It can absorb. Absorption is a surface phenomena. Absorption is nothing but on a solid surface you have a lot of pores, and these chemical, depending on their size, they can get absorbed, they can get fixed onto solid surfaces. Solid surfaces could be soil, could be a sand particle, could be a tree, could be a leaf, could be even your skin. It can go land and get absorbed, get fixed in the pores that are abundantly present in so many parts of environment. That is possible. And they can, if this mass of the size of the particle is very heavy, they can sink down. If it is a river, if it is a sea, if it is a lake, the particle that is on the surface can sink down depending on the mean mass diameter of that particle. So sedimentation is possible. That means chemicals are in some other form, they are transported, they can be reacted into compounds, some other compounds, which could be either less effective or more dangerous. They can be absorbed, they can be sedimented. These are the governing physical principles that happens in the environment. So depending on the process, they get into the sink. Sink means what? They remain, but they are in the bottom. Their presence is there, but they are in the bottom. That means the pollutant was in the surface in a river. After some time, the surface water runs, but the particle remains in the bottom. They settle down. They are not eliminated. That is what you should remember. They are not eliminated, but they are still there, right? As a store, sink. And they can also get what is called sedimented. Sedimentation is that particular process where the particles can settle down. So there will be a clear liquid above. There will be a pollutant or artificial pollution presence in the bottom of the sea, bottom of the river, bottom of the lake, or bottom of the earth, bottom layers of the earth, or some kind of lower layers. If it is your room, it is on the floor. It can sediment. If it is in the lake, in the bottom of the lake, it can settle, in whatever that is in the lowest portion that is holding up that particular system. So it can be transported, it can be stationary. One is dynamic, the other one is stationary. The one is capable of dislocating, locating, or locomotory. The other thing is static, stationary. So it is extremely important. But what is more important is chemical has not been eliminated. They have shifted their places and settled. That is important. When they are shifted and they are present, finally they can land in very targets of environment. Could be human being entry. I told you what is that entry? Through nose, through skin, and through mouth. It can go inside the body. It can go inside the fish. It can go settle on the absorbing surfaces of buildings. It can go and settle on trees. That means these entities which are having their own health now start getting upsetted. They get upsetting starts from now on, because something which is not inside the body, which was outside, has come and attacked them. So depending on their vulnerability, depending on their susceptibility, effects will be causing. So from the source, it moves within the environment, finds the targets, and settles there and creates a lot of reversible or irreversible, what is called chain reactions, that is effects. That is the concept what is called eco-kinetic properties. Movement of the pollutants, movement of the xenobiotics inside or within the environmental compartments. Now, concept number 4 is biokinetic. Now, the xenobiotic, which was in the environment hitherto, has found the portal entry, and now it is coming inside the body, going inside the body. Even inside the body, the movement does seldom starts. Movement will be continuous. Now, what is the governing principles of movement of these pollutants once it enters inside the body is what is this slide talks about. Now let me again represent, in the previous slide I put the compartment as environment because it was all the drama was going on the environment. Environment means sand, water, soil. That is 3 media. That was going on there. But here it has reached the portal entry and gone inside a particular organism. And this organism for us, for practical purposes, human beings, but it could be microorganism, it could be fish, it could be some other environmental entity. So this is the representation in organism. Now within organism, how it enters. So now dose becomes important. That is the concentration of the xenobiotic becomes important. Depending on the dose, starts moving inside the organism in this particular manner. And it can be distributed and metabolized. So there we put transported. Is it not absorbed, transported? That mechanism happened in the with respect to environment. Here, what is happening is it is distributed into internal compartments. Internal compartment means what? One compartment is lung, one compartment is liver, one compartment is heart, one compartment is blood, one compartment is kidney, one compartment is bone, one compartment is brain. Inside there are several compartments, so they can get distributed because there is a common fluid going into all these compartments, and that is blood. Is it not? So blood, when chemical, depending on the dose, it goes to the blood, it gets distributed in the internal organs or internal systems, and it can be metabolized. Once it goes internally to all these organs, metabolism happens. Now what is metabolism? Metabolism is a chain of reactions, multitude in number, millions of metabolic reactions happen, and in this there is an input, process, and a product. That means reactants, process, and the products. That means input is the xenobiotic, external pollutant. Process is what is called enzyme reaction, enzyme mediated reactions, and products are metabolites. It can be metabolized. Once the enzyme acts on the reactant chemical, it gives out enzyme products which are called metabolites. But all chemicals that we get exposed cannot be following the same rule. Some cannot be metabolized at all. For example, lead. Lead is a metal which can never be metabolized. So lead remains as lead without conversion or undergoing metabolism, and as lead itself gets distributed into different organs. In there, the funny portion is these, depending on the quality and also the dose of the particular pollutant, they can get stored also. For example, again, lead gets stored cumulatively, preferably in the bone. So in the bone we have calcium. It knocks off. It has fighting power because it is bad fellow, villain, lead, and it will knock off the hero calcium which is needed and throws him away and takes his place to settle down. That means lead now, which was outside your body, came inside the body. It cannot be metabolized. We don't have that enzymes to degrade it, so it goes and settles in the bone, which is a sink or a store organ, and this is very, very dangerous. That means what was outside came inside, could not be metabolized and thrown out, went inside the bone and settled in the bone peacefully, living there, so that the effect of this particular metal becomes more and more when you become aged, when your age increases. So after about 40-50 years of settling and residing in the bone, then when your immunity power goes down, the danger or diminished qualities of the lead increases and you get a disease called plumbism, lead poisoned. And plumbism does not have any cure. You will have to die. This is the danger. That is the reason why we should understand all the science behind store organs, their capacity of metabolization, their capacity of distribution. So important it is. That is the reason I am telling you in environmental studies, these are all thrilling stories and scientific studies that one can engage and go and learn what happens and what is the fate. In other words, it is not biokinetic property is nothing but fate of that pollutant inside the body, fate of the pollutant inside the environment. So metabolism has two portions. One is constructive metabolism, we call it as anabolism. Destructive metabolism called catabolism. Both are very equally important. One is for constructive purposes. The other one is destructive purposes. For example, respiration is a catabolic property phenomena. Catabolism means what? Burning. That means energy is possible only when you burn, and energy is so much needed for you to work. So catabolism also important. Now anabolism is growth. You have to grow and develop, is it not? You have to become from child to an adult. So that is metabolism. One is growth, the other one is catabolism. Excretion, that is urine formation, is a catabolic process. It is a destructive process. Some bad things have to be metabolized and those metabolic products have to be eliminated out of the body for you to be healthy. So metabolism per se is very important, which has two components, anabolism and catabolism. Both are equally important and significant for the body. Any process which comes in the way of this metabolism, then there is a danger of precipitating into a disease. So the pollutant which was outside and docile came inside and became active, either settled down or metabolized. If metabolism happens, then it is a safe thing, because metabolism itself by and large 98 to 99% nullifies the action of or the bad effect of pollutant, and the metabolic products are generally thrown out either in the form of sweat or urine or feces. It is extremely important. You have to throw out these metabolic products. If they are held, then it is also a problem. So there is always a danger. What can be metabolized are okay. What cannot be metabolized are very dangerous. Like for example, mercury and lead, they are very dangerous. They cannot be metabolized at all. And finally what happens? This is either bioaccumulated over a period of time in your life. The compounds are formed and the metabolite products can be either eliminated, compound can be excreted, right? Can be excreted. And also it is either in the form of the original compound or modified metabolite, also it can be excreted. So it can be excreted. But there are certain compounds which does not undergo metabolism, they get accumulated. It could be in kidney, for example, cadmium goes and gets collected in the cortical portion of the kidney for entire life. So cadmium is it has a philia to kidney, like lead has a philia liking to bone. Similarly, so many other compounds are there which like certain organs, and liver is a very large glandular organ. Liver has a very good function for the body, for metabolism. So that can be affected, lungs can be affected, brain can be affected, kidney can be affected, blood can be affected, or bone can be affected, right? So there is always this exposure danger, and this biokinetic property is that property which is movable or inside the body from compartment to compartment. Next concept is what is known as acid rain cycle. This happens in the environment. Please understand, this is an interesting story. It gives out a lot of sub phenomena and concepts. Acid rain cycle. Now we have seasons, and there is a bio-geo conversion happening. Water gets converted into liquid and solid, and also air, that is the water vapor, right? It has three phases of conversion. And rain is a very, very important, process and extremely important for us because it is the purest form of water. It is fresh water. It is not adulterated, salted or anything. But because it is so fresh, because it is so clean, it can always be, uncleaned. It can be polluted easily. And it is very extremely reason, that is the why we should protect the quality of rain. Now, what is that makes this rain or rainwater polluted, and what are the associated principles, and how it is cyclic in nature, cyclic in the environment, we shall study. Now, if you consider this brown line as the ground, that is ground limiting earth, just for schematic purpose, if that is the earth, there is something below. For example, your lake is below the earth, your sea is below the earth, your well, water well is below the earth, your rivers sometimes are underground, sometimes are overground. So there are so many things that are happening inside the layers of the earth. There is fire inside the in the ground. Lot of heat is inside the earth. Lot of life and biomes are available. Different kinds of environments are possible in the earth. Different kinds of energy and conversion, reconversion are continuously going on inside the earth, and it is extremely, extremely important because it is unseen, we ignore, but it is happening. It is happening. Now, over the ground, also some beautiful drama is going on, and we need to understand that also. Environmental studies, that is why is so thrilling, that it will not leave anything. It is a holistic science where over the ground phenomena we learn, under the ground phenomena also we learn, and on the ground what is happening also we try to learn. Now, acid rain cycle, please remember, we have for typical urban environment, houses, industries, cars, buses, scooters, which run because of the energy given by the petroleum fuel or any other fuel. Energy, for example, energy is needed to burn something to convert, and when you convert, when you burn, heat energy comes out, and that heat in the form of energy, is utilized. It can be transmitted into mechanical form, and things can move. Heat is needed to cook. Heat is needed to melt the furnace and convert the metal into alloy. All those things are possible because day in and day out we are burning these fuels for different kinds of applications. So when it comes the products, whenever you burn, please remember, burning cannot be at any point in time 100%. So something is unburnt. That is number one. Unburnt fuels become pollutants. They are very dangerous pollutants. And burnt pollutants also are dangerous, sometimes because they give you remnants, they give you residues, they change the path of whatever that. For example, if you run a bus, if you go in your scooter for about 100 kilometers, the cloud, the dust which was settling on the ground can become a dust cloud, and people who are in this house, unnecessarily they are exposed to this cloud. Otherwise, it was no exposure at all. Because of the human activity, because of that disturbance, these locomotory things happened and dust came inside your house. So that is extremely important. We should understand by anthropogenic, by human actions, or by industrial actions, or by so many other developmental actions, what is in one particular place can be dislodged, can be displaced to some other, and some other fellow gets affected. So what happens here is these exhaust gases that comes out of the automobiles are majorly oxides of nitrogen, oxides of sulfur, right? Because nitrogen is 73%, 78%. The oxygen is 21%. Majority of the air contains only these two elements, oxygen and hydrogen, oxygen and nitrogen, and all other gases in maybe 1%. That's all. But majority is nitrogen. So air is needed for the engine because it is air fuel mixture ratio that is to be burned, because oxygen that is present in the air, nitrogen that is present in the air, they get into what is called heat, and when they are heated, they become respective oxides. nitrogen became nitrogen dioxide. There are 14 oxides, 14 types of nitrogen oxides, which we call it as NOx. X represents that 14 number, 14 oxides, NO, NO2, NO3, N2O5, N2O3, like that. You know, you have about 14 forms of nitrogen that carbon. So our nitrogen dioxide is formed because that is major, because it is the major portion that is present in the air, and air is needed for the engine to burn. There is, without that air, explosion cannot happen there. Just with fuel, explosion is dangerous. So air acts in so many functions in the internal combustion, and because there was nitrogen in the air, nitrogen became nitrogen dioxide because oxygen also is present in the air. These two became combined in that environment of heat that is generated into oxides of nitrogen. And what was nitrogen, what was oxygen in the air, after coming out, they become oxides of nitrogen. Oxides of sulfur. Sulfur is an integral compound of fossil fuel. Sulfur element is integrally present in all the fuels, petrol, diesel. Sulfur is a very, very dangerous integral component. It is inside our body. So when your body is burnt, sulfur comes out, you know. So all these fossil fuels have sulfur. The air has nitrogen. These two major oxides are called acid oxides. They are acid forming oxides. The oxides of sulfur also are many, SO2, SO3. Oxides of nitrogen also are many types. But out of that, SO2 is soluble, NO2 is soluble. Soluble in the sense you have a lot of water also in the environment. For example, even in the peak of summer in Bangalore, it will be around 60% humidity in the air. Humidity means what? Water percentage. So when water is present in the air, when oxides of sulfur present in the air, sulfur dioxide, sulfur trioxide to some extent get converted in the medium of environment and become what is called sulfurous acid. Like that, nitrous oxide, nitrous acid, HNO2. HNO2 is nitrous. And nitrous oxide, when it gets converted in the presence of oxygen, becomes nitric oxide. So other acid oxide, that is, this H is H plus, which gives acidity. Nitrous, nitric, sulfuric, sulfurous acids have been formed in the environment. Now, what you will have to understand is, what is in the environment? Primarily nitrogen, oxygen, sulfur. They are elemental in nature. They are called primary pollutants. They are elemental. They are freely available. Nitrogen gas is freely available. Oxygen freely available. Sulfur freely available. They are all gas in the gaseous from the environment, but they are capable of causing harm. So they are primary pollutants. That is source pollutants. They can also become secondary pollutants, like sulfur became sulfur trioxide, sulfur dioxide. Nitrogen become nitrogen dioxide, nitrogen pentoxide, nitric oxide, right? So what was original nitrogen became nitric or nitrous and nitrogen dioxide, nitrogen pentoxide. This nitrogen dioxide coming from nitrogen is a secondary pollutant because it is formed in the air. It is formed outside the source. It formed inside the internal combustion engine, which is also outside the environment. So what is formed in the environment is called secondary. What was present as it is as a component of the atmosphere, that is primary. You need to understand. So this is a very important concept, primary and secondary pollutants. For all practical purposes, primary pollutants are not very dangerous from the point. They are dangerous. Their presence is dangerous, but comparatively they are not dangerous from causing health effects, whereas secondary pollutants are highly dangerous. They highly give greater diseases because of their potential inherent properties, inherent disease causing properties. So primary pollutants are those which are unconverted as it is present. Secondary pollutants converted in the environment, either in the internal combustion or in the environment at the upper layers. And these acidic gases in the presence of water become acids, lower acids and higher acids, sulfurous, lower, sulfuric, higher, nitrous lower, nitric higher, carbon, then carbonic acid, carbon dioxide, carbon monoxide comes out of the engine, combines with oxygen, becomes carbon dioxide, and carbon dioxide, as all of you know, is highly soluble in the moisture and becomes carbonic acid. So these acids, once they formed, they can never be converted into, safe chemicals. They have become most dangerous now. What was docile, it has become dangerous in the environment. And when they are all present in the what is called aerosol form in the environment, especially in urban environment, where automobile exhaust, automobile burning, automobile fuel burning is maximal, right? So all are in the environment. They get converted and interconverted and remain in the environment as aerosol form. Except in the season like rainy season, when it precipitates, when the rain falls, when the water gets down, because of highly soluble nature of carbonic acid, sulfuric acid, nitric acid, this acid gets mixed with the rain, which is so pure, so distilled, so nice, and acid rain falls. Acid rain falls. It falls, and acid is such a dangerous element. It's a dangerous chemical. Acid can dissolve everything and anything. They are highly dangerous. They cause a lot of what's called acidic problems, right? So they can disfigure your paint, which is beautifully you have painted outside. They can disfigure, they can dissolve the paint. They can go inside the earth, earth, they can permeate inside the earth and finally go inside the lotic and lentic systems like lake and rivers, right? The acid get mixed in the water which was otherwise poor now become acidic water, and in the acidic nature in the water bodies, these fishes get affected. They don't like acid, but if acid falls, acid contamination happens, they die. Their health is upset, they cannot reproduce, their health is completely deteriorated. Similarly, your plant, acid photosynthesis is not possible because it is corrosive in nature. All these acids are corrosive in nature. So what was in the gaseous form went into aerosol form, went into what is called acidic form, came down as liquid pollutant, touched the earth and gone into and created liquid water pollution. And this water doesn't remain water forever. In summer, some of the water gets evaporated. So acid present here also gets evaporated. So again, acid which was in the water came outside as an aerosol. So this is a very vicious cycle. What is in the earth comes out, what is in the air goes down. This is what is called acid rain cycle. And this is cumulative in nature because there is no cleaning possible. Over a period of age, the acid rain, what is this year, if you do the pH estimation, after about 10 years, the pH definitely increases because they are not completely neutralized. There is no, alkali rain at all, right, to neutralize it. So acid rain cycle is such a dangerous phenomena, which is cumulative in nature. The production of crop, the health of human beings, the health of plants, the health of buildings, everything gets upset by acid rain cycle. That is one. Second one is the interconvertibility, that is from primary to secondary pollution, is also a dangerous phenomena. Primary pollutants are docile, not very dangerous. Secondary pollutants are very dangerous. Now, I will give you one small example and stop about this acid rain cycle phenomena. See, there is carbon monoxide, the hydrocarbons, because these are all hydrocarbons, because petrol itself is an hydrocarbon. So hydrocarbons are always present in the environment. There is always oxides of nitrogen because of the exhaust, oxides of nitrogen, hydrocarbons. In the presence of sun, in the presence of sun, a drama happens between hydrocarbons and the, you have the sun's rays as the energy, and water as also present in this. Somehow, whatever that is, some deadly concoction happens, and a product like what is called peroxyacetyl comes out. Now, peroxyacetyl is a secondary pollutant that is formed in the environment, And peroxyacetyl is a carcinogen, cancer producing substance. Whereas carbon monoxide, sulfur monoxide can give you only acid. Peroxyacetyl, if you get exposed, you can get cancer. See the danger now, right? So there are so many such complicated chemical and physical reactions that are happening, conversions, interconversions from primary to secondary pollutions happening. Finally, what is happening is the danger of dangerous pollutants in the environment. Dangerous pollutants in the environment solely because of the anthropogenic activities, human created activities. Factories human created, buses and local traffic is human created. So this is how we should be very careful what we produce, and we have to have address all these dangerous things into solvable, manageable and livable environment, and that is where environmental studies come in the picture. So this is the concept of acid rain cycle. Next concept. This is interesting, please understand. This is, now we know the air, and air we don't have good quality, we have converted that into bad quality. Air is contaminated. One of the contamination is acid. There could be so many other contaminations in the air. And air is the single largest component that all the biological species, not only man, is in need. That is, oxygen is so essential for living. Aerobic organisms, which are majority in nature, they all depend on oxygen. The 21% of oxygen at the sea level, which is unadulterated, should be 21% forever. It should not be reduced. If that proportion is reduced, the oxygen proportion gets reduced. And when oxygen proportion gets reduced or oxygen depletion happens, then it irregulates or it causes irregularities in the metabolic reactions of other organisms. Now, one such concept is what is known as human beings' biological air need. That means for all biological metabolic reactions that is happening inside the body, oxygen is very, very important. That is why lungs are very, very important. So now man's life is totally dependent, not just with water, but also oxygen. Oxygen is more important perhaps. In fact, air is more detrimental. At least water we don't drink continually all the 24 hours. Whereas air we breathe every time, every breath. So air is so essential, so much necessary. So we should be bothered about air quality too much than any other thing, because that is very determinantal. If it is not cared, it can be detrimental, it can be dangerous. So what is that biological air need? We need to understand. There is a subtle concept you have to keep in your mind. The first is this particular air need, air necessity for the human body, that is human body, depends on the activity that you are doing. It is not the same amount in all the type of activity that you are inhaling. When you are resting, that is when you are sleeping and not doing any activity, or only sitting and just lying down, because you are inhaling and exhaling, you take about 7.4 liters. That is a person. This is a research finding. I am telling you, this is a research finding, right? A 68.5 kg person, man, when he rests on an average, consumes 7.4 liters per minute of air. That is amounting to 12,600 liters per day. Even though you are not doing any work, even though you are just lying down, even though you are just sleeping, that means 12 kg of air. If you put it in the balloon and weigh, the amount of 12,600 liters weighs about 12 kgs. Now, please remember how much we eat. We eat hardly about 1.5 to 2 kilos. So what we eat is just a fraction of what we inhale. See, such a interesting fact here. We think that we are eating more, but what we are doing more is we are inhaling more. So activity also becomes very important. When you rest is that quantity. When you indulge in light activity like office work, or just walking without doing heavy work, just walking, doing some moving activities, the consumption increases. 7 became 4 times more, right? It is almost nearing to 3.5 to 4 times more per day. If you indulge in just light work, like office typing work, clerks, or administrative work, walking, that is light work. The amount of oxygen that is needed is still more, many 3 to 4 times more. But when you do heavy work, like lifting, running, briskly walking, and that is, we also do that such activities during the day. If it is heavy, you see, what was resting is 7, now it is 44. What was 12 became 69, 3.5 to 4 times more, right? So this is a startling information that you should keep in your mind, that air is not same quantity at all the time. It depends on the activity, your physical activity. It is linked to physical activity, right? On an average, you can say, if you make this average with average activities, definitely it is a big amount, big volume, many times more than what you eat and what you drink. Why I am telling this? Because if small pollutant, even though small concentration in a big media like air is present, because you are taking every breath, chronic effects come. Chronic effect, you should remember. What did I say? Chronic, small amount in a long time. Okay, in a large volume, even small amount of pollutant becomes extremely serious. That is the reason why air pollution is more dangerous than water pollution and other types. All pollutants are dangerous, but relatively air pollution is more dangerous. That is number one. Number two, air pollution, air does not have boundaries. You can have Karnataka and Andhra Pradesh boundaries, but air does not have the boundary. What is in Karnataka can go to Andhra Pradesh. What is in Tamil Nadu can come to Bangalore. There is no boundaries. That is why air, for as water at least has boundaries, because it is running on the soil, on the land. But air is not like that. So pollution becomes a objective principle. Tamil Nadu should be concerned, Karnataka should be concerned, India should be concerned equally, and United States should be concerned, because there is no boundaries, right? That is the reason why air pollution is more dangerous, more detrimental, more concerned of all the other pollutants. Now, basic concept number 7. Because it is so important, we try to learn another concept of air pollution, that is called air quality. Now, what is quality? Quality is nothing but what is called the presence of substances which are not normal components. They are all formed components as secondary pollutants in the atmosphere in concentration so much big enough that a detectable, measurable damage or disruption can be seen, causing health effects and economic activity or natural and artificial systems. Now, what is health of Taj Mahal? It's an economic activity. What is white marble can become black marble. So what was white was pleasing, what is black is not pleasing. So the quality became, that is the quality of aesthetics became very, very less because of the bad air quality, right? So that is also a danger, that is also a disease. It could be for the building, but it is a disease, right? It is not doing the purpose. We build such good, marvelous buildings because it is nice to look at, nice to live in, nice to appreciate. If that quality also comes down by your contaminants in the air, then the quality of that building or disease of that building has occurred. So it is important. Air pollution, that is how defined as the presence of substances in the environment, air, water, soil, in high concentrations to produce measurable disruption or diseases. That is called air pollution system. We have 3-4 more slides. We will see what it is. Now, air quality is very, very important. I have told you that it is the single largest component that all biological species utilize, extremely critical. And in air, we mean actually about oxygen. In air, what is the lifeline, life giver is oxygen, although it is present in lesser amount than the bigger amount of nitrogen. Nitrogen is not life supportive. It is inert. It is not at all reactive. It does not oxygenate your blood, right? So it is present. We can't do anything. That is the default. But this presence of 21% oxygen in the environment is highly, highly critical. And if there are so many n number of pollutants other than oxygen, oxygen being reactive can get reduced because it takes part in the reaction because of the reactant nature, highly reactive in nature. So oxidation occurs. When oxidation occurs, the amount of free oxygen that is available for our life gets reduced. So the presence of oxidants itself is a danger. We should have elemental oxygen for the life oxygenation of the blood for us to keep our health. So this 21% becomes very, very critical. If by chance oxygen content becomes less, that is around below 16% from 21%, then the diseases starts, precipitating. Anoxia is less amount of oxygen for all organs inside the body, especially for the brain. And when brain is devoid of oxygen, irregular metabolism happens. Metabolism is millions and millions of enzyme processed or enzyme mediated reactions which convert one to the other. That is extremely important inside the body. It has to happen. That will get irregular in nature if the concentration of oxygen is less. If the concentration by chance becomes less than 6% from 21%, life cannot exist. You get choked. You get what is called asphyxia. You get the death is the only way, right? So oxygen becomes, or oxygen concentration in the environment becomes critical, and air quality is totally determined by the amount or percentage of oxygen that is present in the environment. Baseline or normal or very good percentage being 21%, which is the maximal oxygen concentration, right? So this becomes the reference percentage. These become very dangerous or danger signal giving, when we should get back, convert this depletion to this, pumping up. Third basic related to this one is air pollution system. It causes, what are the causes? What is the origin of this air pollution? It is power burning. I told you many times. It is energy, extraneous energy for human comforts like automobiles, trains, planes, and other things. They are needed, but we should be cautious that they should not deplete the oxygen. They should not increase the polluted concentration. So we will have to do a lot of research to give the nature its original quality of 21% oxygen. For that, we need to take cognizance of when we build automobiles, when we build trains and planes. Keep that in your mind. You're all engineers. So you have to keep in your mind when you build or when you innovate things, this particular basic concept, which is the life molecule that can never be depleted. Else you get into disease mode. You get into metabolic disorder mode, right? So it is extremely important. Now, nearly all this power comes by burning of fuels. It could be solar fuel, it could be hydrogen fuel, it could be biofuel, it could be petroleum fuel. In petrol, diesel, kerosene, petrol, gasoline. It is fuel burning for energy purposes, and this burning causes air pollution. So air pollution is a human-caused, anthropogenic, artificial, human-created problem, and only humans have to solve that. We need to realize it. Now, this is the last slide in the air pollution system. And here you see, I told you the system is always parts hooked together to create some kind of comfort, to create some kind of good thing, to create some performance, right? So emission sources are there. Chimney is a classic, just for ease of understanding I am giving you. This is a exhaust that is coming out of this one is a emission source. Emission means emission of air pollutants or xenobiotic source to the environment. Why? How it comes? Transportation, electrical power generation, refuse burning, industrial and domestic fuel burning. These are all some of the activities which give emissions and which are emitted finally to the medium of environment. So they cause various kinds of pollutants, several thousands. There are 200,000 nature of pollutants. They give these pollutants to environment which was otherwise clean. They get into the atmosphere. Atmosphere is that blanket of air that is above the ground level and where we human beings are living. And so we get exposed to these pollutants which is in the environment, that is in the atmosphere. We talk about this little later. Atmosphere is also a very interesting entity. And then it gets transported. It gets physical and chemical forms. It gets into, causing damage to weather pattern, climate pattern. Natural systems are aberrated. They are altered. So atmosphere itself, that health is altered by presence of pollutants. They exert that kind of change. Sometimes in the environment, in the medium of air, which is also a mobile, moving entity, depending on the presence of humidity, moisture, wind current, air pressure, wind pressure, other wind temperature, and other all things, pollutants are transformed, like I explained in the acid rain cycle. Mixing of chemical happens. When mixing of chemical happens, some different kinds of atom collide and react, and products are formed. Secondary pollutants are formed, right? And then finally, these pollutants, which are docile and also dangerous, get into the body of human beings. I told you the eco and biokinetic properties. They get into the body. They become the receiving organs, receptor organs. They could be human beings, they could be animals, there can be plants, microorganisms, and even be engineering materials, including your house building, right? This is the complex, I should say, picture of air pollution system. Now, why I am putting in this form is, this is the problem dimension, and we need to control. So there is a control engineering that is possible. Pollution happens, but pollution should be controlled. Control is nothing but bringing down the levels to safe level, so that the disease is not happening, so that the discomfort is not caused, right? And where it is possible, how it is possible, I'll give you a clue now. You can either put some aberration in the process where the source itself, see that very minimal pollutants are coming out because of the technology that you use inside the industry. You try to minimize toxic pollutant emanation in the source itself. That is one best way. Controlling at source is the best way. But sometimes, in some cases, not possible. And these pollutants in the environment, it is there. There you can control. There you can put some kind of controls engineering that is possible. That is in the path. Sometimes, if that is also not possible, you will have to have your mask so that the pollutant is not entering inside your body. At the personal level also, guard is possible, but that is at the last. That is the last priority of control. This is second priority of control. This is the first priority of control. Priority here, second priority, last priority. So control also is possible once you put the things in this particular pictorial or stage-wise form. What is that pollutant? Where it is? Can I control at the source? Can I control in the path? Can I control in the target? Now I give you a classical example how it can be done. Say for example, industries produces lot of noise which is unwanted, very annoying, very dangerous. They can create a lot of what is called deafness and auditory, non-auditory effects, psychological effects, right? So noise is produced. So noise is a pollutant. It is a xenobiotic. It travels in the medium of air. Noise cannot traverse in vacuum. So noise traverses in the medium of air. So, and it will touch the portal entry, that is the ear, right? So source is industry, path is environment, and portal entry is human ear, right? At 3 levels, you can put the engineering control. Here, see that it is silence, put silencers, put absorbing material for the noise so that noise is reduced at the source. You can also put it during the environment by increasing the distance between the source and the person, increase the distance. You let the industries in one area, residents will be about 50 kilometers away, which is the town planning in Western countries. You can't have factories where the houses are there. So you increase the area, or the what you call it as abatement area. That is the engineering of the path. If that is also not possible, put a ear muff, put a ear plug, so that noise doesn't enter inside the body and disturb you. But putting ear plug and ear muff should be last. When you exhaust the conditions of increasing the path, putting the silencer, then this is how you can plan what is called abatement. This is also known as recognize what kind of pollutant, understand what kind of pollutant, what is its quality and quantity. This stage is called appraisal. If you will have to measure the quantity and compare to threshold limit value, which is called assessment. Then you will have to abate, control that particular export, which is called abatement. Appraisal, assessment, and abatement. 3 A's are the stages in control engineering and control systems. That we will learn a little later. But now it is enough for you to understand that there is an air pollution system. And why air pollution system we talked so much? It is so much important because it bothers everybody. It bothers everybody. It is very, very dangerous. It affects both human beings and as well as so many other entities. It does not have boundaries. It does not discriminate from region to region. We cannot engineer what is, how and when, what is that complex mode of transfer. Suddenly a cyclone can come, suddenly a temperature can come, suddenly a rain can come, very, very dynamic atmospheric conditions. But these pollutant affect them and pollutant affects them. So that is reversible, right? So that is the reason why we talked about air pollution system as a system for quite long. This will be the last slide. Factors of pollution. There are only 3 factors you need to remember, and by this time you know it. But these factors are extremely important. Amount of that is locally present, that is locally available, that is near your breathing zone. Breathing zone is nothing but taking nose as the center, 2 feet and make a circle. Anything comes in that circle, you are amenable for breathing. That thing can go inside, right? So that is amount present locally, very important in defining pollution, which we call it as tonnage. It is nothing but quantity. It is nothing but concentration. It is nothing but dose. I have explained that dose very in detail. Now it is easy for you to understand. First factor of air pollution is the dose. What is the concentration? Then the harm that it is possible to cause. What is that harm it can cause? For example, if there is a respiratory aberration, is one. If there is a nervous aberration, it is something else. So nervous aberration is more dangerous than respiratory. It is less dangerous for stomach and kidneys. It is like that. You will have to prioritize. Everything is damage only. You have to prioritize. If a chemical damages your stomach, if a chemical damages your lung, if a chemical damages your brain, which one will you give priority? Chemical which damaging your brain is more priority, is it not? So toxicity. All are bad only. You will have to answer. But priority wise, if all the 3 are affected in the same body, your brain, stomach, and also the respiratory system, you give priority to the brain, then you give priority to the lung, then you give priority to your stomach, right? So toxicity, poisonous capability of pervasive capacity of causing damage is toxicity. Poison creating or poison inducing or poisonous nature of the pollutant is the next factor. That is called toxicity. The third one is how much you are exposed to this kind of quantity and this kind of quality. This is quality, this is quantity. How long you have exposed. If it is more, then dangerous. If it is less, also sometimes depending on if this is more, that is also dangerous. But that is a determinant. That is a determining factor. So this tonnage, this toxicity, this time, I put all in alliteration TTT. So we call that as 3 T's. Factors of air pollution is tonnage, quantity, toxicity, quality, time, duration, that is dose. Dose, all this become very, very important for putting up control measure for tackling the control abating measures. I think I will stop at this. We have covered about 8 basic concepts. There are 4 more which we will cover tomorrow, and we'll move on. Please, if you have questions, you will have to have questions. I at least expect 10 to 15 questions every session. List out your questions, share with either Professor Abhijit or Shubha, so that we can talk. We can have half an hour session, question answer session at the end when we complete this particular module of basic concepts, right? Thank you very much. And we will meet tomorrow around at 9 o'clock. It is at 9 o'clock, 9 to 11 tomorrow. We will talk and try to move ahead with our coverage of topics. Thank you very much. Thank you.
Thank you, sir.
Abhijit, it is okay? So
Thank you, sir. Thank you.
Thank
Yes,
you.
sir. Yes, sir.
Thank you. Thank you. Thank you.
For 9 o'clock. Hello?
Hello?
Yes, sir. Yes, sir. I'm able to hear you.
Yeah. So tomorrow at 9 o'clock, please organize. Please be present.
Yes, sir.
Yeah. Thank you. Thank you.
Yes, sir. Thank you, sir.